So, ngayon, ituro ko paano gamitin yung beam analysis using stiffness method using extract software for English units. So, suppose we have a problem. So, mayroon tayong problem dito. So, determine the moment developed at support A of the beam shown in figure 15.1a. Ito yan. Assume that the roller supports can pull down or push up the beam. Take E, the elastic modulus, as 29,000 psi, and the moment of inertia as 510 inches to the power. So first is we need to model the beam in the software. So we have 24 and we have 8. Yan. So I assume that point A is the origin. So we have here point A is the origin. So this will be 0 and 0. So in English units, so dimension in length must be in inches. So na-observe, nakita natin dito sa problem na naka-fit siya. So kailangan natin yung i-convert. So gagamitin natin yung calculator command dito. So this will open the Windows calculator. So open it. Ayan. Ayun. So makikita natin dito, click mo lang yan. So makikita mo dito kung standard lang or scientific or converter. So yung converter, punta ko dito sa length kasi gusto ko ma-change yung 24 feet to inches. So kung gusto mong baguhin yung units dito, click mo lang yan. Marami yan. Then also with this one. So in my case, I will use feet to inches. So type ko yung 24. Ito. Type ko to. 24. Ay. Again. 24. Ayan. So we have 288 inches. So ito din yung equivalent niya. X. So 288. Type ko yan. So this will be 288. Then 0. Ayan. So automatic yung beam model will be updated into inches. Next nating i-model is yung ito. We have 4. So 24 plus 8. 24 plus 8. That is 32. So kailangan i-model natin yan. So kailangan mag-reference tayo lagi at origin. So punta tayo ulit sa converter. So type ko lang yung 32. Ayan. So we have 384 inches. So type lang natin yan. 384. Then 0. Ayan. So automatic mag-update din yung model. So next nating, pagkatapos nating ilagay yung model, members model, ilagay naman natin yung mga supports in the beam. So makikita natin dito sa figure na meron tayong fix at origin, roller at point B, and roller at point C. So punta tayo dito. So fix daw at origin. So 0, 0. So makikita natin, automatic mag-update din yung fix. Then meron tayong roller at 288 inches and 0. Ayan. So ma-observe natin, meron tayong small circle. Then another roller. So huwag mo lang ipagtabi yung dalawang ordinance kasi magko-connect yun. So leave ka lang ng isang space. Then lagay mo ulit yung kung saan siya nakalagay, 384 exact. Or this is 32 feet. So automatic mag-a-update. So ito na yung beam model natin. So once lagay na natin yung beam model, punta tayo sa property. Click mo lang yung icon na to. Ayan. So makikita mo. Ito yun. Then we have 3 members. So in our case, dalawang member lang naman yan. So input na natin yung dalawang member. So yung length in inches, makikita natin dito. Ito yung member 1. Mababa tayo. So ito yung member 1. So ito. This will be 288 inches. Then yung code number niya, makikita natin dito. Yung code number, ito yun, 43 vertical moment. So 4, 3, 5, and 2. 4, 3, 5, and 2. 4, 3, 5, 2. Then, sabi niya dito, sa given sa problem, na yung elastic modulus is not assume 1 or constant. So, meron siyang value na binigay. Ilalagay lang natin yan, 29,000 PSI and 500 pa. So, this is 29,000 PSI and 510. So, yung area is not given, so I will assume that that is equal to 1. Or, let's say, area is constant. So, once matapos na natin yung member 1, lagay tayo ng value for member 2. So, for member 2, ito yan. Dito na part. Yung from B to C, yan yung member 2. Ito, which is represented by a number inside the square shape. So, this will be 8 feet. So, pupalit tayo dito. So, since, assuming hindi mo alam yung conversion, click mo lang din to para ma-access mo yung conversion. So, type mo lang yung 8. So, automatic, that is 96 inch. So, lagay natin yung 96. Ay, okay. Ay, okay. 96 inch. Then, yung code number, ito yan. So, we have sa member 2, 5, 2, 6, and 1. 5, 2, 6, and 1. 5, 2, 6, and 1. Then, the elastic modulus is similar with the member 1. So, lagay lang natin lahat. So, tapos na tayo sa member 2. Member 3 is not wala tayong member 10. So, punta tayo sa loadings. So, yung pag-complete ng loadings, that is manually. So, lalagay mo lang yan dito. Ayan. So, I'd rather choose manual computation for loadings. So, makikita mo yung computation ng loading na ito. Dito yan. So, next is here the beam has 2 unconstrained degrees of freedom. So, yung 2 unconstrained degrees, yan yung magiging last code natin. Then, the matrix analysis of proper external is determined by or expressed by this displacement and load matrix. Load matrix. So, meron tayong 04, then 14408. So, ito lang yung ilalagay natin. 1441008. Lagay ko yan, 144 and 1008. Then the last code is, so this also represents the 2 entries. Meron tayong 1 entry, 2 entry. Or lagay mo lang yung 2. So ito yan. Then mag-assign tayo ng units. Dito, pwede mong computein yung loadings. Pero I'm not used to it. So dito na lang ako diretso yung units. Ayan. So, makikita natin dito sa problem na yung code 1, 2, and 3, lahat yan naka-moment. So, dapat naka-moment din tayo. So, lagay natin yan dito. So, 1, 2, and 3 naka-moment yan. So, key edge. Key edge. Key edge. Then, next is yung 4, 5, and 6 natin vertical force. So, expected that will be K lang, no? Yung tips. So, yung tips, lagay natin tips. Then, next yan, puntahan natin yung na-compute natin mga loadings dito sa baba. Ito yan. Silalagay lang natin yan. So, yung concern lang man natin is yung member AB. Okay. AP. Ito, no? So, ilalagay natin yung for number 3. So, bawal maglagay. Kung dito naka 1 and 2 yan, dapat 0, 0 yan dun sa forces. Bakit na? Tama. So, 0, 0 yan. So, pag 1 and 2, 0, 0 yan. 1, 2. So, dapat 0, 0. Yung dito. 0, then 0. Then, yung 3, 4, and 5. 3, 4, 5, and 6. Yun yung lalagyan natin ng value. So, may kita natin dito na yung dito may moment yan, which is 96 key inch. 96 key feet is equivalent to 152 key inch. So, ilalagay natin yung 152 for number 3. So, yung code 3 represent number 3. So, lagay natin 152. 115. Then, for number 4, makikita natin dito. So, for number 4, meron tayo dito. Ayan. So, since ito lang yung calling ko, I think needed na siya. Pwede ilagay din natin. So, meron tayong 24. For 4, we have 24. Lagay natin yan. Ano yan? 24. Okay. Keep kasi yan. So, walang problema. Ito lang yung may problema. Next is ito. Meron tayong 24 tsaka 6. So, lagay natin yan. 24 and 6. So, since dalawa yan, 24 plus 6, that is 30. Lagay natin 30. And for the last, for code 6, makikita natin dito na 6 pa rin siya. For 6, we have 6 kN of force. And similar yung direction nila, so assume natin na positive lang din. Then, assign na natin yan sa beams. Click natin yung beams. Okay. Save, then close. Then, ito i-assign din natin. Save. Then, close that. So, once na-finish na natin yung result, pwede na natin i-open yung show beam stiffness matrix. Kung gusto mo stiffness matrix lang yung kukunin mo. So, click ko to. So, mag-update yan. Hintayin mo lang. Okay, I think tapos na. So, yan na. So, makikita natin dito yung stiffness, structural stiffness. So, pag zoom in natin yan, ayan, makikita na natin yung value. Diba, amazing yan. So, ma-observe nyo na equal talaga yan sa conventional. So, yung conventional niya, ito yan. Ayan. Try natin, ha. So, apply ko dalawa yung sorry, Windows. Oops. Ayan. Then, ito din. Piligas ko ng konti. Ayan, no? So, ma-observe mo 616.250, 308, then 00, then 9628.91, then negative 9628.91. O, diba? So, 9628.91, and so on. 200. Pareho talaga sila. Ayan. So, balik tayo ulit. So, yung individual, ito yun. Individual, kung gusto mong kunin din yan. So, pwede na natin i-clear yung stiffness matrix. So, baba tayo naman. So, click mo lang to para ma-clear lahat. Then, hintayin mo lang din. Matapos yung updating ng Windows. Sige. I think update talaga siya. Amazing siya. Hihintay na lang ako sa masusunod ako. Ayan, no? So, I think finish na. Yung pag-clear. Ayan. So, kung gusto natin kunin yung final output talaga, so ipakita lang natin yung show beam calculation and results. So, makikita natin, once we click this checkbox, makikita natin yung solution tsaka yung final result. So, click natin yan. Ayan. So, mag-update yung Windows, makikita mo. Tumatakbo siya. Nandiyan lang siya sa disk. Ayan, tapos na. So, tanggalin nyo lang to, no? Yung, ano yun, nakatanggalin nyo yan. Ayan, so, yun dito, this shows the final output. Then, ito naman yung solution. So, medyo mahaba-haba talaga. Aralan nyo lang. Ayan. Yan yung solution. Then, yung concern ko lang dito, yung ito. So, zoom in ko to. Check natin kung equal ba talaga yan sa conventional. Medyo mabigat-bigat talaga yung software. Ayan, check natin yan. Ayan. So, may observe mo dito, yung D1 is negative 0.467347 times 10 to the negative 3. So, tama talaga. So, rounding up lang. 1, 2, balik tayo. 1, dito yan. 1, 2, and 3. So, tama talaga. 1.402, so tama pa rin. So, ayan. So, nakuha natin yung value for D1. And next is for yung Q. So, masolve natin yung Q. Pero dito, pinapakita lang niya dito yung value ng Q3. So, ito lang yung value ng Q3. We have 144 key inch. So, solve natin. Then, yung MEV naman, yan yung value ng R3. Ito yan. 1296. So, pareho lang yan sa 108 key feet. So, convert natin yan, yung key feet na yan. Convert natin yan. So, ma-observe mo dito, na yung 108, clear ko yan, 108 is equivalent to 1296. So, that is also equal to 108 feet is equal to 1296 inch. So, 108 kips feet is also equivalent to 1296 kips inch. So, I think that's it. So, yan. Ay, pala. Pwede din natin i-clear yung output. So, clear ko yan. Kaya kung di mo na kailangan yan, pwede mong tanggalin din yan. Pindutin mo lang yung clear beam calculation. In automatic, mag-update ulit yung Windows. I think tapos na. Ayan. Ayan, so thank you.